So in this section, we're going to do something called piecewise functions. Piecewise functions have pieces. So I want you to notice this first one, f of x equal, and we have two different pieces, 2x minus 1 if our x values are greater than or equal to 0, and x squared if our x values are less than 0. So we're going to graph this thing, and we're going to start with the first piece, and we're going to think of it as y equals 2x minus 1, and then we'll deal with this domain restriction here on the right. So y equal 2x minus 1. I'm going to go to a picture. I've already written y equals 2x minus 1 here, and I'm going to graph that. Now, I want you to remember from algebra that y equals mx plus b is always the graph of a line, and our slope is sitting in front of x, and we can make it into a fraction by putting our whole number over 1, and then our y-intercept is out to the side. Our y-intercept here is -1. So first thing I'm going to do is graph that y-intercept on the y-axis. I'll put my -1. There it is. Now my slope is 2 over 1, which tells me to go up 2 over 1. If this had been a -2, I would have gone down 2 over 1. So up 2 over 1. So from this point, up 2 and over 1 puts me right here. All right, and now I'm going to try and draw as straight a line as I can going through these points. Granted, I'm not very perfect when drawing with my mouse. It's not very straight, but we get the idea of what it's supposed to look like if I could actually draw straight. All right, that's pretty crooked, but all right, so there's my line. But now let's go back for a second. I have this restriction. My x values have to be greater than or equal to 0. All right, so here's the x value of 0 right here where my pencil is pointing. Everything over here to the right I want to keep because I want x values that are greater than or equal to 0, which means if I think of my x value as being a vertical line, I want to get rid of anything to the left of that vertical line. All right, so I want to get rid of all of this over here. So I'm going to go ahead and get an eraser, and hopefully it won't erase every... Oh, I erased a little bit of my axis by accident right there, but all right, so I have erased, that's the piece of that line that I want to keep. Now let's go to the second piece, y equals x squared. Our x squared function, let me go ahead and change colors so we distinguish these two. I'll call it that color. Our x squared function, remember, was one of our library functions. And I'm going to, oh, got to change back over to a pen. I'm going to draw that x squared function. Remember that it's a parabola. And this isn't very perfect, but looks something like this. All right, so there's my parabola. Now, I want, however, x values less than 0 for the parabola. When we have a no equal sign with our inequality, it means that we need an open circle at that x value. So I need an open circle right there at 0. And since I want x values less than 0, it means I need to keep the left-hand side. I've got to erase the right-hand side. Now I'm going to have a little bit of trouble erasing and not erasing some of that blue line, but I'll get the blue line back if I need to here. So if I erase, yeah, I'm going to erase some blue line by accident. And I'll put the blue line back. All right, so there's the graph of my piecewise function. Now remember, this one's a solid dot right here because we have an equal sign with our inequality, and this was an open circle, meaning that there isn't actually a point there. So if we did the vertical line test, this would pass the vertical line test right there because there is no point right there, but there is a point right here that it's hitting. In fact, anywhere that we draw our vertical line, this will pass our vertical line test. And it's very important when you get done, it must pass the vertical line test. And if it doesn't, you've done something wrong in what you've erased. So let's go on to our second example, and we're going to graph a piecewise function that has 3 parts. So now let's notice our first part here is another line. Y equals negative x plus 1 is in that form y equals mx plus b. So let's graph it first. Let's notice the y-intercept is 1 and our slope is negative 1 over 1. All right, so I'm going to just rewrite y equals negative x plus 1 over on my graph. And remember, whenever, and I know that looks like a not equal to sign. Remember, when there's no number written out front, it's actually a 1, in this case a negative 1, since we have a negative x. All right, so I can change that negative 1 into a fraction for the sake of my slope. My y-intercept is a 1, so we'll go to 1. And put that on there. And then my slope tells me to go down 1, right 1. So from this point, down 1, right 1 puts me right there. And now I'll graph this line, try to be straight. And I'll draw a little bit further up here. All right, now we're going to erase part of this line depending upon what our piecewise function says. We need x values less than negative 1. So if I go back over here, here's negative 1 on the x-axis. Think of a vertical line going through my negative 1. I need x values less than negative 1. So I need everything over to the left. I need to erase from here over. Get rid of this ridiculous thing. Okay, so let me erase right here. And I might erase a little bit of my axis by accident, but I'll get it back. All right. Now, since there was no equal sign with our less than symbol here, at the end of this graph, we want an open circle. So I want this to be an open circle. All right. Now, let's go to our next piece. Our next piece is 3. Well, y equals 3. Let's go back here. And again, let me change colors for the different graph here. I'll go green for this one. And y equals 3. Recall from previous algebra classes that the graph of y equals 3 is a horizontal line with y value at 3. All right, so horizontal line with y value at 3. So let me draw that horizontal graph at 3. Notice that I'm going through the y-axis at 3. All right, but now if we go back to our original, we need for our x values to be between negative 1 and 1. So here's the x value of negative 1, and here's the x value of 1. I really only want my graph to be from here to here. So in other words, I only want it to be from here to here. All right, think of your x values as kind of spanning vertical lines. So you need it from here to here. So let me erase the rest. And I gotta be careful here, try not to erase my blue line. Come over here, try to get right up to negative 1, and then all the way out here. Gets erased. All right, now let's go back and check here. There's no equal sign next to the negative 1, so that's going to be an open circle at negative 1. So open circle here. And then the other side, however, had an equal sign. So at the 1, there is a solid dot right there. All right, now let's go to our last piece and graph it. We have the square root of x. That's one of our library functions. So let's graph the square root. And I'll change colors again just so we can distinguish. Oh, pink, why not? All right, so recall that the square root was this rising picture. And it looked like a hill, kind of like this. All right, so there's our square root graph. However, If we go back, we need x values greater than 1. So here's the x value of 1. If I go up from here over is what I want, not this little piece right here. Let me erase right there. Try not to erase the axis. All right, and then if we look back here, there is no equal sign with that greater than symbol, so I need an open circle right there at 1. And there is my piecewise function. Notice again that it will pass the vertical line test. Right here, there's an open circle and an open circle, so it won't be hitting twice there. Right here, there is a closed circle and an open circle, so it'll only be hitting once, and everywhere else, it passes the vertical line test. It does not pass through the graph twice.